Today we'll start a new topic, DC machine, that is called the armature winding. Let's start the whiteboard first. Then I don't know why it is not coming. Am I audible?
Yes, sir.
Yes, sir.
Okay. So let me start the whiteboard. I don't know why the whiteboard not coming. So how long you had that class today? BJB search class. When did it end?
Up to 6:15.
From 6:15 to
To 7:15.
7:30. Okay. Now I should share the screen. Now I think it is visible, isn't it? Is the screen visible now? The
Yes,
whiteboard?
sir. Yes, sir.
Okay. So today we will start armature winding. You know what is the armature in a DC machine? Which portion is called the armature? But the armature winding is not related to DC machine only. In any machine, there will be some armature. There, one component is called the armature, another component is called the field that you have in any machine. But in this particular machine topic, machine subject, that machine one, electrical machine one, will read only the DC machine armature winding. Okay, but a few definitions will be valid for any kind of armature windings, DC, AC. Okay. Now, few definition. We first we should know the definition. First is the conductor. Okay, so what is a conductor? Conductor is basically a wire or strip of a conductor, strip of you can say conducting material, which we use uh, uh, to flow some current or to get some voltage induced in that. So we can write, by definition, we can write this is the active length for this length of a wire. Okay, and that is kept in a slot. Okay, so first, that is the conductor. Now the second definition, we should know what is a turn. There is a difference between the conductor and turn. So what is turn? A turn consists of two conductors. As I mentioned, when I derived the voltage expression for DC machine, I already mentioned that the turn consists of two conductors. of two conductors. Okay, now if I draw a particular coil to understand what is turn and suppose this is a coil. Okay, now this portion and this portion is called a conductor, and this is another conductor. So this is conductor 1 and conductor 2. But as far as turn is concerned, this is only one turn. You can understand like this. Okay. Now uh, this is this you can say this is a coil which is made of one turn only. Only one turn. It is made of only one turn. So that means when a coil is made up of one turn, then a turn means two conductor. This I already explained in my previous lecture. Okay. Now if I have a coil which is made up of n turn, that will give me 2n number of conductors. Okay, so this is how turns, conductor, and the coil is related. Okay, so next, obviously, the next definition will be coil. Okay, so coil may have a single turn, coil may consist consist of a single turn or may consist of okay, so many turns. Okay, so when it consists of many turn, it is called a multi-turn coil. Okay, in case of many turn, it is called a multi-turn coil. Multi-turn coil. So generally, we use the multi-turn coil uh, in case of DC machines. Okay. Now, the difference between two coil sides. Okay. Now, before that, we should also define the coil side. Then we can use this term coil sides. Okay. So a coil consists of two coil sides. Okay, so which are placed in different slot. So coil sides are placed in different slot. Now the difference between two coil sides is generally called the coil span. So that means Suppose let us draw a coil which has two turns like this. Okay, so this is how we are making two turn coil. Okay, so that means two turns here, two turns here. Now there is difference between two coil sides. So this is one coil side, one coil side. Okay, which contains two turns, or rather two conductors. Here also this coil side will contain two conductors, but this difference is called the coil span. Okay. Now the coil span in case of DC machine generally uh, is a full pitch. Full pitch means, I think I have explained na, full pitch. Did I explain what is full pitch?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, suppose for an example, uh, suppose a DC machine, suppose four pole and number of slots, uh, it has 36 number of slots. Now what will be the coil span if the coil is a full pitch coil? Can you tell me?
So 9 slot per pole.
Correct. So
That means
the coil span is 9 slot. 9 slot, not 9 slots per pole. That is okay, slots per pole. But I want
actually 9 slots.
coil span. So that is one full pole pitch means 9 slots.
Yes.
So coil span is 9 slots. Is that clear? So if it is a short pitch coil, so generally short pitch coils are not preferred for DC machine. I can explain that, but not now. So you can mark it. Okay, so short pitch coils are preferred for AC machine. So short pitch coils are preferred for AC machines only. Okay, so if the coil is short pitch, then what can be the coil span? Coil span must be less than 9. Is that clear? It can be 8 or 7. Not very less. Either by generally it is shorted by one slot or maximum 2 slots. Is that clear? So short pitch means for short pitch the coil span should be less than 9 slots. It can be 8 or 7. Okay, okay. Accordingly, you can calculate the short pitching angle. So if it is, for an example, if it is short by one slot, if the coil span is 8, Can you tell me what is the value of epsilon? Do you know what is epsilon? I think you don't know, no? Okay.
Short pitching angle.
Angle.
What is that angle? If it is sorted by 1 for this case, so it is short by
Sir, 20 degree.
1 slot.
20 degree.
20 degree. How?
Sir,
Correct, I think. But how?
total
10
span
degree.
180 degree.
Huh?
Sir, 10 degree.
No, 20 degree. I think.
Sir,
Okay. Now let us calculate. Actually, full pitch means equivalent to how much angle?
10 degree mechanical actually.
Full pitch means full pitch is always electrical angle.
Electrical.
So one full
Yes,
pole
then
pitch.
electrical 20 degree electrical.
Full pitch. What do you mean by full pitch?
Hmm.
Full pitch.
180 degree electrical.
So it is 180 degree electrical. 180 degree electrical. Always you should remember one full pole pitch. One full pole pitch means only 180 degree electrical. Okay, so if it is 9 slot, so coil span is 180 degree in terms of degree, and in terms of slot it is 9. Okay, for a full pitch coil, in terms of angle it is 180 degree, in terms of slot it is 9. But for a short pitch coil, if it is sorted by 1 slot, then 1 slot corresponding to how much angle? So 9 slots corresponding to 180 degree. Okay, so that means 1 slot equivalent to 180 by 9, that is 20 degree. Okay, so that means the short pitching angle will be 20 degree. So always all the angles are calculated in electrical angle. Is that clear? So let us see whether I have got some chat. Okay, so it is not 10 degree, but it is 20 degree. But when we use for the voltage expression, we use actually cos epsilon by 2, then the angle is generally 10 degree, because epsilon by 2 is 10 degree. Okay, but the short pitching angle is basically 20 degree in this case. I think these concepts are clear. So another name of this short pitch coil is called the corded coil. Corded. Either short pitch coil or corded coil. There are two names. It's also called the corded coil. Short pitch coil or corded coil, which is preferred for AC machines only, not for DC machine. Because if the coil span is less, then the maximum flux linkage by any coil in a machine will be reduced. Okay, and if the maximum flux is reduced, then the voltage induced will be reduced, because in the voltage expression there is a flux, maximum flux. Like if we go for this voltage expression for DC machine, ZA by AP phi n, now that phi is basically the maximum flux linkage, so that will be reduced. Okay, so unnecessarily we don't want to sacrifice the voltage induced, so therefore we use the full pitch coil in a DC machine. But for AC machine, we sacrifice that voltage, cost of a different thing. So that is not our discussion here. Okay, so there are two types of windings available for DC machine. One is called the single layer winding, and another is the double layer winding. Not only DC machine, the double layer windings are generally used. But in general, there are two types of winding. You should know these terms: single layer and double layer winding. Single layer and double layer. So there are two types of winding used for the DC machine. Now single layer means in one is in a slot there will be only one coil site, only one coil site. Now this coil may have a different different turns or different conductors, but only one coil side will pass through it. Okay, so that is called the single layer winding. Is that clear? That means a single layer winding may consist of different conductors, but it is a one coil site. So same coil site. Same coil site. But in a double layer winding, we have a separation, an insulation, and the top we have a coil side, in the bottom we have another coil sides. Okay. Now this also may have several conductors like this. Okay. So this is basically one coil side, this is basically one coil side. So there are two coil sides. Okay, so this is called the single layer winding and this is called the double layer winding. So double layer means there are two floors. One coil sides will be in the first floor, another coil sides will be in the second floor, just like. Okay. Now, for a single layer winding, which is actually there are different types of slot as well. I should not go that details anyway, but you should know this. This type of slots are called the open slots. Some slots are there, which is called the semi-closed slots, and some slots are there, which is called the closed slots. So these are the core. So this is one type of slot, and this is a closed slot. So this is open. Now for the singular winding, we can use semi-closed or closed slot. Okay, so that is the advantage of single layer winding. And what it is done that from one end of the on one end we can push the conductor to the slot, and at the end we can make the connections. So that is the advantage of the semi-closed or closed slot. It is the single layer windings. Okay, but for double layer winding, we generally use the open slots. Okay, so the double layer windings are more, you can say, more common for most of the machines, and for DC machines we use only the double layer winding. Okay, and also we get the symmetrical winding in case of double layer winding. Now go to the specific discussion for DC machine armature winding.
Sir,
Hmm. Bolo.
sir, ডাবল লেয়ার ওয়াইন্ডিং যেটাতে
হুম।
ওটাতে দুটো কয়েল সাইড একসাথে গ্র্যাপ করা আছে, মানে ইয়ে করা আছে, ওয়াইন্ড করা আছে। তো
হুম।
বলছি ওই দুটো কয়েল যেটা ওই ফার্স্ট ফ্লোর আর সেকেন্ড ফ্লোর যেটা বললেন, ওর মাঝে কি কোনো
হ্যাঁ।
সেপারেশন থাকে, মানে কোনো
ইনসুলেশন, হ্যাঁ,
ফিজিক্যাল
সেপারেশন থাকে।
সেপারেশন থাকে কোনো?
হ্যাঁ, ফিজিক্যাল সেপারেশন থাকে,
আচ্ছা আচ্ছা,
ইনসুলেশন
তো
থাকে।
তাহলে তো স্যার নিচের নিচের যে কয়েল সাইডটা,
হ্যাঁ।
তাহলে তো এটা ক্লোজ স্লট হয়ে গেল।
ক্লোজড না, ক্লোজ স্লট নয়,
না
ক্লোজ।
মানে আমি বলতে চাইছিলাম,
হ্যাঁ, বলো।
আচ্ছা মেটাল সেপারেশন, আচ্ছা
Not
ইনসুলেটর
metal
দিয়ে
separation,
সেপারেটেড থাকে।
insulation, not metal separation.
ওকে
That is the insulation is there.
ওকে ওকে স্যার, স্লটের মেটেরিয়ালটা দিয়ে, ওকে ওকে ওকে।
Is that clear? That is the insulation, not the. I will show you the actual. Actually, if you don't see what is the actual
স্যার
thing,
ওটা একটু দেখালে ভালো
I
হয়।
will show that. I will show all this how the coils are
ওকে
made.
স্যার,
Before that, some definitions you should know, because as a
ওকে
designer, you should do something in pen and paper. Okay.
ওকে স্যার, থ্যাংক ইউ।
So DC machines windings are basically diamond shaped windings. Okay, they are basically double layer winding. So we use double layer winding and mostly open slots. Open slots and full pitch coil. Diamond shaped coils. Why it is diamond shaped coil? I will show that. So the coils are like this. I don't know whether I can draw it in this whiteboard because it is very difficult to draw something with this type of board, but still I can try. You should also try to draw. And if we see it from the peripheral view, it will be like this. Suppose here you have a slot and another slot will be here, because in these two slots, two coil sides. So this is one coil side and this is one coil side. These two coil side will pass through these two slots. So obviously, in this coil, one will pass. So this is the middle. So one will pass through the top coil side, top slot, top portion of the slot, and one will pass through the bottom portion of the slot, bottom coil side. So this is how it will pass. So let me show like this. So this is one coil side and this is one coil side. Okay, so this is how we use the diamond shaped winding. So in a DC machine, then it is generally uh, a full pitch coil, double layer winding, where the one coil side passes through the top portion of the slot, and another coil side passes through the bottom portion of the slot, because there are two layers, top layers and bottom layers. So one uh, coil side pass through the top layer, another coil side pass through the bottom layer. Okay. Now here what I have drawn in this particular case, there are only two coil sides per slot. There can be more than two coil sides per slot, like this. So suppose in case of two layer, so there can be three coil sides or six coil side in this case. So six coil sides per slot in this case. Six coil sides per slot. Six coil sides per slot. So how we should know how we name these coil sides? Like this, we have the slot. Okay. Now, how we name the position, different coil side position, we should know. Now, always the top coil sides are odd and the bottom coil sides are even. So like this, we name it like, so one, sorry. So this is 1, this is 2, this is 3, this is 4, 5, 6, then 7 will come here, 8, 9, 10, 11, 12. So always we'll have the odd coil sides at the top and the bottom coil sides at the even coil sides at the bottom. So this is how the coil sides are numbered. Is that clear? Is that clear? So what is the coil numbering of the coil sides? Now I will show some video, because otherwise it is a monotonous lecture. So I will stop the share and I will try to show some video where you will learn how the windings are generally made. So just give me 1 minute. Let me open the video. Okay, just a minute. Where the video?
Commutator, bar to bar, test okay.
Can you see the video?
Then we put the E.
Can you see the video?
First off, we test the core, test okay.
Yes, sir.
Okay.
Then we test it.
Can you tell me that what is this portion called?
Sir,
Anyone?
commutator.
This is the commutator.
Commutator.
And
Bar to
what is this
bar.
portion where these leads are housed? Can you tell me? Which is
Riser.
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 correct? Is the riser.
Okay.
And what is this portion at the right? At the right, what is
Armature.
this? Okay, so this is the armature core. Okay, this
Yes,
is made of
armature
steel.
core.
We put the equalizer in. Run the commutator and test OK. Test OK.
Okay, so I'm just-
Insulation paper and
okay, so
each
these are the
slot.
insulation papers. So this is how they are inserting the insulation paper in the slots, and these slots are
All
basically
the
open slots. You'll
insulation
see,
going to the slots.
so all the insulation papers are housed in the slot. Okay, so you see, this is the diamond shaped winding. Just I have drawn. Can you see that? So one front, that front portion will go pass through the top coil sides, and the back portion will pass through the bottom coil sides.
Now
This is how he this is how
slide
he places
the
the coil in the slots,
into the slot and we connect
and
it
the
to
ends
the
are connected
we
to the
connect the
risers,
winding to the commutator bar.
to the commutator and riser. So all the coils, they're connected to the risers. Okay, so here they're using 3
Okay.
coil sides, or there are rather 6 coil sides
Now
per
all the
slot.
bottom coils
So that
are
means
in
for one coil
the
sides,
commutator,
there are 3.
and we
One
begin
layer,
to
there are
put
3
the
coil
top
sides.
coil into the commutator. Okay, now all the wire is in the slot and it connects to the commutator. Okay, now then is trimming the excess paper, insulation paper coming out of the slots.
So
And
excess
this
insulation
will
paper
later
they
be
cut
folded
like
and
this.
covered by a paper strip. They insulate. And after that, we have the strip.
This is how they close the insulations.
Okay, now we have wrapped the armature with the fiberglass bending.
So this is the fiberglass wrapping they have used.
We go
That is
around
another insulation.
the,
Then they will send
armature
this for
connection,
the varnish impregnation.
and we go around the top stick to in place.
So this is the armature they have made.
Before it gets dipped
So
in the
this,
varnish.
then this armature they send to the some heat chamber.
Okay, now the armature is coming out of the oven, 200 degrees, and it's gonna cool down to about 145 degrees before it goes into the dip tank. Okay, now and it's ready for
When
dip.
it cools down to 140 degrees, they dip into the varnish tank. So this tank is full of varnish.
Okay, it's time time to raise the armature for the dripping of the varnish. We're gonna leave the armature suspended in the air for a certain amount of time, so okay.
Okay. So I think you have understood how the coils are made and how the coils are placed on the stator slots, isn't it? So do you have any question on this? Anybody has any question? Okay, so if you don't have any question, then I'll proceed. There are two types of winding, as I mentioned. DC machine winding types. Lap and wave. Okay, so you know that for lap winding, the number of parallel circuits equals to the number of poles, and for wave winding, the number of parallel paths equals to constant, that is 2. Now here also for this lap and wave winding, we should know a few terms like very important thing which will be required for the winding design. Don't forget this term. হ্যালো, হ্যাঁ বলুন। হ্যাঁ, আমি আমি একটা ক্লাস নিচ্ছি, আমি কি একটু পরে আপনাকে কল ব্যাক করবো? আর ওই ধরুন হাফ অ্যান আওয়ার পরে আমি কল ব্যাক করি। ও আচ্ছা আচ্ছা আচ্ছা, মিটিং মিটিং আচ্ছা মিটিং, আচ্ছা ঠিক আছে, আমি দেখি এটা শেষ করে তাহলে ওটাতে জয়েন করবো। ঠিক। Okay, so the back pitch is defined as the distance between top and bottom coil sides of a coil. Okay, so it is defined as the distance between top and sides of a coil. Okay, so that is the back pitch. So another thing is there, that is called the front pitch. Front pitch. What is the front pitch? Front pitch is the distance between two coil sides. Again, the distance between two coil sides. Coil sides connected to a same commutator segment. Connected to the same commutator segment. First write down this, then I will discuss in details. Now the third definition is the winding pitch. Winding pitch is the distance between, again, okay, so let me write this, the distance between the starts and ends of two coil, my ends, coil sides of two coil. Okay, you can write distance between the two coil sides of the same coil. And the fourth one is called the commutator pitch. The distance between two commutator segments. Segments to which two ends of a coil is connected. Okay, now generally this back pitch is designated by YB. This is designated by YF. This is designated by capital Y, and this is YC. So these are the definitions only. Now go to the actual thing. Before that, I should draw a sample conductor so that we can understand these terms very clearly. Now, let us draw two poles, pole face rather.
Sir, sir,
বলো, শুনছি
sir,
শুনছি
এই
বলো।
winding pitch আর coil span এই দুটো কি সেম?
না, ওয়াইন্ডিং পিচ আর কয়েল স্প্যানটা সেম নয়। আমি একটু পরে দেখলেই বুঝতে পারবে। ওকে, আমি একটা জিনিস তাহলে ভুল করেছি, এখানে কি সেটাই বোঝাচ্ছে? Then we have to, okay, two coil sides of a same, not a same coil. Okay. Distance between two consecutive coils actually. Coils. So let us define like this. Two consecutive coils. So distance between two consecutive coils. That is called the winding pitch. Now it is, I think, understood. They are not same at all. So let us draw one coil. So this is the commutator, and these are the coils. So I have drawn two coils. So coil number 1 and coil number 2. Okay. So here, suppose this the coil side 1 of coil 1 passes through, suppose slot number 1, or not slot. We should say the coil sides 1, because the naming we know. Suppose this is how the slots are named. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now let us take that this is a slot number, coil side number 1. So this is your 1. Now it will return back to the commutator through some bottom coil sides. Let us take that is 12. Okay, so let us take that will return back from 12. That means, so I am using these two position. So this is the position and this is the position I have used for the coil number 1. So this is the coil number 1, one coil side, and the second coil side is passing through this. We should write coil number 1. Okay, now what is the back pitch according to the definition? Can you tell me what is the back pitch? Can I define the back? Can I calculate the back pitch from this?
11.
Why 11? Because according to the
Because
definition of the back
12
pitch,
minus 1.
according to the definition of the back pitch, it is the
12 minus 1.
it is the difference between distance between two coil sides, or bottom coil sides and top coil sides and bottom coil sides. Here the top coil sides are 1 and bottom coil sides are 12. So that means the back pitch will be 12 minus 1,
11.
11. Can you tell me, can it be a even number?
No, sir.
Why?
Because it is always odd minus even. So it should be always odd number. One coil side is at upper layer, which is
Even minus odd.
designated.
It is always even minus
So
odd.
even minus odd, that is designated by some odd number, is
Correct.
even minus odd.
So
odd
always the
numbers.
back pitch should be an odd number. That you should remember. If it is not coming an odd number, then you have to adjust to make it an odd number. Okay. Now, before going to the other thing, that means the front pitch and winding pitch, we should define the second coil. Okay, so the second coil, let us take as the second coil uses the coil side 3 for its top coil sides, and 14 here it is using 12. So the second one means it is using this and another here. Okay, so it is using 3 and 14. So again we'll get the same back pitch, that is 11. So 12, 14 minus 3, again it is 11, isn't it? So always the back pitch will remain same. Not only back pitch, all the pitches will remain same for a particular machine. Now, can I calculate the other thing, that is the front pitch and winding pitch? Can I calculate the front pitch and
Yes,
winding
sir.
pitch? What will be the front pitch? Now, according to the definition, let us go back
9.
to the definition. So, what is the front pitch? The distance between two coil sides connected to the same commutator segment. Now, you see, you just find out the same commutator segment means, suppose the number 2. So, what are the coil sides connected to 2? So, the coil sides which are connected to commutator segment 2 is 12 and 3. So, we should subtract 3 from 12. That means it is 9. Okay. Is that clear? So, how to calculate the front pitch?
Yes, sir.
Now, how to calculate the winding pitch? So, winding pitch is the distance between two consecutive coils. Now, what will be the winding pitch in this case? Again, the winding pitch is also measured in terms of coil sides. So, all the pitches are measured in terms of coil sides. Okay, so here the units are coil sides, not angle, not distance, nothing. Only in terms of coil sides, the pitch, the winding pitches are measured. Okay, so what is the winding pitch in this case? Two consecutive coils means coil 1 and coil 2. Take two similar coil sides and take the difference.
2.
2.
Answer is 2.
So that means 3 minus 1. So I can take this 2 or I can take this 2. So two similar, to find out the difference, we have to take two similar coil sides. Either two top coil sides or two bottom coil sides. So anyway, you will get the same for both. So it will be 2. Okay. Now from this we can establish a relation between this winding pitch and other two pitches. That is, the winding pitch is back pitch minus front pitch. For particularly here, this type of winding, which is called the lap winding. Here I have drawn the lap winding. So here the laps are found. So for lap winding, we can write here also we can prove that it is 11 minus 9, that is 2. So the winding pitch is back pitch minus front pitch for lap winding. Now what is commutator pitch? We missed that. What is YC?
1.
Okay, so what is the definition of commutator pitch? The distance between two commutator segments
2 commutator segments in
to
which
which
the
ends
two coil sides of the same coil are connected.
two coil sides of the same coils are connected. So here it
The
is
same
1
coil.
and 2. So that means it is 2 minus 1. That is only the difference between the other pitches and commutator pitches is that the commutator pitch is measured in terms of commutator segment, isn't it? So here it is measured in terms of commutator segment, and the back pitch, front pitch, and winding pitches are measured in terms of coil size. Okay, so that is the difference. Is that clear? So this is how it is measured. Now, if we take the back pitch, how we can calculate the back pitch in general? Suppose I have C number of coils. C number of coils in a machine. Okay, and in a p-pole machine. C number of coils in a p-pole machine. So what will be the expected back pitch? Can anybody estimate that? Okay, so let me explain that how we can estimate the back pitch from these two values. Okay, suppose we have C coils. Now, how many coil sides are there?
2C.
2C. So that means C coil sides. C coils means 2C coil sides. Each coil will have two sides, which are called coil sides. So C coils mean two C coil sides. Okay. Now these two C coil sides will be distributed over how many poles? P number of poles. Okay. Now in case of lap winding, as you can see here, if one coil side is on a north pole, another coil sides will be in the next south pole. That is the criteria. So if the top coil sides are passes over the north pole, the bottom coil sides of the same coil will return back over the south pole. Okay. So that means almost one full pitch it is taking. So in terms of coil sides, what will be the full pole pitch? If this is the
2C by P.
correct. So that means it's very clear that total number of coil sides are 2C. And in how many poles they are distributed? P. So 2C by P. So this should be the back pitch. Okay. But it should be what type of thing? It should be an odd number. It should be an odd. If it is not odd, then you have to make it odd by some adjustment. That adjustment parameter is plus minus k. So k can be any integer or fraction to make 2c by p this value an odd number. Is it clear? You just see whether it is clear or not. So the back pitch is defined as 2c by p plus minus k. This will be required during the winding design because that will be the starting point of any winding design. So back pitch will be 2c by p plus minus k. Okay, and another two things you know that for this type of lap winding, the front pitch, not only sorry, not front pitch, the winding pitch is always 2 and the commutator pitch is always 1. Okay, so these are the things you should remember for this type of lap winding. So there are different types of lap winding, which is called the retrogressive lap winding. This is called the progressive lap winding, where we are getting the positive values of back pitch. Okay. So I'm not going to that. The next day I will discuss the retrogressive winding. What is the retrogressive winding? Here you see here the coil is starting with the coil size 1, returning back to the coil size 12. Okay. And it is starting from the commutator segment 1 and it is returning back to the commutator segment 2. For retrogressive winding, it will end at some commutator segment here. Okay, as if it is not progressing, it is going backward. In that case, your the commutator pitch will be not +1, it will be -1. The winding pitch will be not won't be your 2, it will be -2 in that way. In case of retrogressive winding, the winding pitch will be -2 and the commutator pitch will be -1. Okay, so that I will discuss in the next class because I have to show that by the winding, and then we'll discuss the wave winding. So after that, we'll go for some numerical problem, numerical design problem. Okay. So let us now see whether you have any question on this. Any question? You should remember the
Sir.
follow.
স্যার বলছি অ্যাডজাস্টিং প্যারামিটারটার ভ্যালু কিরকম হবে, মানে কোনো ফিক্সড রেঞ্জ আছে?
যতটা কম অ্যাডজাস্টমেন্ট করা যায়। সাপোজ ফর অ্যান এক্সাম্পল,
ওকে
যদি তোমার 6 বেরোয়, হ্যাঁ, তাহলে তুমি যেটা করতে পারো যে 7 করতে পারো, মানে অ্যাডজাস্টমেন্ট ভ্যারিয়েবলটাকে 1 ধরতে পারো, তাহলে 7 নিলে ওটা অড নাম্বার হয়ে গেল। মানে নিয়ারেস্ট অড নাম্বারটা বানাতে গেলে যতটুকু অ্যাডজাস্টমেন্ট করতে হয়, না 6 তো হতে পারে না। ব্যাক পিচ cannot be 6 because back pitch always should be an odd number. Okay, suppose if the number of coil sides at 24 and if the number of poles are 4, so then it will come around okay, so it will come 6, but 6 cannot be the back pitch because it's an even number. So to make it odd, either you have to make it 7 or you have to make it 5. So both you can use. Either you can use the back pitch 7 or you can use the back pitch 5. So that adjustment you have. Okay. Anything?
ওকে স্যার।
Anything else? So I think you have understood there is some similarity between the back pitch and the coil span, but the coil span is measured different. Actually, the coil span is measured in number of slots, and the back pitch is measured in terms of coil sides, isn't it? Coil span is also measured in terms of angle, but the back pitch is measured in terms of coil size. So that you should remember. So this difference, this very small difference you should observe, you should remember. So I think you don't have any questions, so let me take the attendance.
স্যার
বলো। মঞ্জুর আলম মিদ্দে।
স্যার ওই ভিডিওটা পাঠাবেন, ওই ভিডিওটা যেটা দেখালেন না আপনি,
পাঠাবো?
ওটা একটু পাঠাবেন।
হ্যাঁ, পাঠাতে পারি। I
ওটা
can
পাঠান।
share the link. I will not share the video because that will take around 110 MB upload data. I will share the link, but because that is available in the YouTube. So all I have the video I have connected from YouTube.
ওকে স্যার,
I will share the link. You just see that. Okay. Anything
Okay.
else?
থ্যাংক ইউ।
Okay. So let us take the attendance. So I have another meeting.